Today's lesson is continuation of section 2.7. Yesterday we talked about actually finding square roots or finding the square root of a number. Today we're going to talk about approximating square roots. What if they give me the square root of some number that, as I call it, doesn't give me a nice answer? Like, for example, square root of 25 gives me just 5. So, again, I would call this a nice answer because it's something that won't have a decimal. And in fact, it's a whole number. Or square root of 81 gives me 9. So sometimes in class or a lot I'll say these are nice answers that we get. But what happens if I get square roots that do not give me nice answers? There's still a way we can approximate those even without our calculator. We can make a guess at what they should about be. Maybe like 5.8 or 6.2. Like we can make some kind of guess maybe to the nearest tenth at what that number should be. To start off though, I want to talk about the difference between these two things because both these things we're going to see a lot this year, and we need to understand the difference between the two. There's something called the square of a number, and then there's something called the square root of a number. When we square a number, what we're actually doing is taking that number times itself. Like if I want to say 5 squared, that means 5 times itself, which is like 25. Okay, kind of like I mentioned here a second ago. This is squaring a number. It also comes from, again, if you think about actual square, and I want to find the area of it, well, both these sides will be the same, 5 and 5, if it's a square. So 5 times 5 gives me 25. This is what we're doing when we square a number, or 7 squared means 7 times 7, which equals 49. So that's squaring a number. The square root of a number, again, is when we make this symbol right here that looks like a check mark with a line over the number. So let's say square root of 25. That's saying what number times itself gives us 25. That number is going to be 5. The square root of 9 means what number times itself gives me 9. In this case, that's 3. So just one thing we need to kind of keep track of, we will see these again and again this year, is what happens when we square a number, or when it talks about taking the square root of a number. Those are two entirely different things. They're inverses of each other, but we do need to understand that those two things are different. Something else we need to talk about for this section are things called perfect squares. It's actually a certain group of numbers that we're referring to when we talk about perfect squares. I'm also going to bring this little diagram down because this refers to what a perfect square is, or kind of shows us also. Perfect squares are numbers that I can take the square root of and get as I say, a nice number, or get a whole number, you could say. So they are formed from literally a square, like 3 times 3 gives me 9. 9, this is a perfect square. If I take 3 times and find the area, so it's talking about the area of a square. Or if I have 4 times 4, let's say I have a square with dimensions that are both sides are 4, then 4 times 4 gives me 16 for the area. 16 is a perfect square. The lowest perfect square is actually 1. I could have a square that's just 1 by 1. The area that would be 1. So 1's the lowest perfect square. The next one would be 4. 2 times 2 gives me 4. 3 times 3 gives me 9. 4 times 4 gives me 16. 5 times 5 gives me 25. 6 times 6 is 36, and so on. I can find more numbers like this, and these are all perfect squares as we call them. So 64. 9 times 9 is 81. 10 times 10 is 100. I'm just going to list a bunch here that we will see. 12 times 12 is 144, and again, there are many others. But I find those essentially just by taking some number times itself. That will give me a perfect square. This list is going to be very important for us today when we're approximating square roots. We're usually going to use these numbers to figure out and estimate what the square root of some number is going to be. These are going to kind of be our reference points as we're doing that. On this next page here, it says approximating square roots. To approximate a square root, we're just going to look at the perfect squares. There's what we were just talking about, that list I had you write down, or that I did want you to write down. If you haven't done so, you definitely should write down those numbers and have them in your notes. So you have some examples of what perfect squares are. We're going to look at the perfect squares that are closest to that number and estimate what it would be if it has to be between the perfect squares that are around it. So, for example, here's what a problem might look like, and I'll show you kind of how this works out. So let's say we have a number like 20. We're going to take the square root of 20. Well, again, the square root of 20 is not a nice number. It's going to be an irrational number, as we've talked about here in class. But what I want to do is I just want to make a guess at about what is the square root of 20. What I'm going to do is I'm going to go back, or I can look at my list here, going back a page, look at my list of perfect squares. Where would 20 fall in? Well, it'd fall in between here, 16 and 25. And so what I'm going to do is I'm going to think of, well, what are the square roots of 16 and what are the square roots of 25? 20 must be between those two numbers. Square root of 16 is 4. Square root of 25 is 5. 20 is about right in between those. So what I'm going to do is I'm going to make a guess, maybe like 4.5. That's going to be my guess for what the square root of 20 actually is. On the assignment today, this is what I'm going to want you to do. I want you to make a guess at what you think the square root of that number is. Then what you can do is you can actually take your calculator and then use it and check and see, well, what is the actual answer? Well, it looks like the actual answer is 4.47, and if I round that to the nearest tenth, I'm going to round it to 4.5. So there's the actual answer. On your assignment, you can even do this, put the actual answer there, put your guess, your approximation in a box. Oops, I got to spell it right here though. Good thing it's on the page for me. Approximate. So when they give you a square root, I want you to not use your calculator right away. I want you to approximate what the answer is first, and then go ahead and punch in the actual value on your calculator and see how close you are. And hopefully we get within a few tenths. That very next one, square root of 63. Again, some people, I think, as you go on here, you'll start to remember what some of the perfect squares are, so you won't have to look them up. But for this one, we'll also go back on that last page and say, okay, where would the square root of 63 be? Well, it would fall somewhere right in there. The square root of 64 is very close, obviously, just a little bit bigger. So I have a square root of 64, just a little bit bigger than it. Square root of 49, my other perfect square that's just below it. Square root of 49 is 7. Square root of 64 is 8. So I know that the square root of 63 must be some number in between that. It's going to be 7 point something. I'm going to take a guess of maybe like 7.8, let's say. So that's my guess. I'll put that in a square. Again, you don't have to necessarily label this each time on your assignment, but I can say that's my approximate. You can just label it by putting a square around that number. If I want to find the actual number for square root of 63, I can punch that in my calculator now that I've made my guess. And it looks like square root of 63 is actually 7.93 and so on, 725, some numbers after that. So, but here's the actual. So I'm going to put that right below my guess. But if I'm within a few tenths, I feel pretty good about my guess. So that's what we're going to try to do, is guess within a few tenths, maybe 1/10 or hopefully right on, and make an approximation for the square root they're giving us today. On this next page here, I'll just go through a few more examples. So I have numbers 6, 7, 8, and 9 here. So I'm going to do is 6 is square root of 97. Again, I'm going to make an approximation by picking the perfect squares that are around it. And I won't go back to that page. Again, I'll say that I've kind of started to memorize some of those. But if you need to use that page, you can. I know that 100 is the next perfect square after 97. I know that 81 is the one below it. And again, how do I know that? Well, I kind of memorized that 100 is a perfect square, and I know that's square root of that is 10. And then I know that the one below it must be 9, and that's 81. 9 times 9 gives me 81. So again, just kind of memorizing that I know some of the perfect squares myself. But again, if you have to reference that page, that's fine. So I know that square root of 97 must be between 9 and 10. I'm going to make a guess of 9.8. We'll see how close I am. Square root of 97, as I punch it in my calculator here, says it is about 9.8. So my guess was pretty close. Again, maybe I'll circle my actual answer, put a box around my guess, and see that they were actually pretty close. So that was pretty good. Square root of 51. Well, I know one perfect square that's just a little bit under that is 49. Square root of 49 is 7. Well, that means that 8 times 8 must be the next perfect square above that, and that's 64. So I know that square root of 51, whatever it is, it must be 7 point something, somewhere in between these two. And it looks like I'd say 51 is a little closer to 49 than it is to 64. So I'm going to say like 7.2 as my approximation. As I punch in the square root of 51, it looks like it's actually about 7.1. 7.14, so I'm going to stop at 7.1. So again, I would definitely accept that as a close enough guess. If If somebody was taking that, putting that answer in a quiz or on their homework, that would be close enough for me. Number 8, 405. Again, this one obviously a little bigger, and so maybe I have to kind of try yourself to punch in some numbers to say, okay, what's a perfect square that's around that? Let's say you're just kind of taking a guess yourself, and you say, well, 18 times 18, what would that give me? Well, 18 times 18 gives me 324. So I have the square root of 324. Okay, that's close, but maybe not quite close enough. 19 times 19 I can try. 19 times 19 gives me 361. Okay, well that's getting closer to 400, so maybe now I'm a little, that's not quite the perfect square I'm going to use, but we'll see here. Maybe that is the lower one on the end of it. 20 times 20 just gives me 400. So I think that's definitely the one that's going to be right under here, so I'm going to use that one. So again, just so you don't know perfect squares that are nearby that near that number, see how you can still just kind of guess yourself and just kind of keep working up towards the number. And as soon as you get to that point, now I found the perfect square I can work with. It's 400. So the next one must be 21. 21 times 21 is 441. So those are the perfect squares that are around 405. Well, again, 405 also is a lot closer to 400, though, so I'm going to guess something closer to that. I'm going to say this is going to be about 20.1. Let's say it's real low, or at least real close to 20, 20.1. As I punch in 405 and take the square root of that, I'm getting that the answer is about 20.1. So far I've been pretty good at guessing. That last one has negative square root of 35. Again, even for one that has a negative with it, I'm still just going to pick the perfect squares that are close by to 35. So don't worry so much about the negative right away. That's just telling me to make my answer negative when I'm all done. In terms of perfect squares that are close to 35, I think 36 is right next to it. So, and that's 6. And then the one that would be below this would be 25. Square root of 25 is 5. So I know then that the square root of 35 is going to be 5 point something. This one, in this case, is really close to 36, right? It's closer to the upper end, so it's going to be like 5 point, let's say 9. And then again, I just have to remember that it's negative, so I'm going to say negative 5.9. When I take the square root of 35, I'll see what I get. Yeah, it is about 5.9, it says. And again, I'm just going to make it negative. That negative sign doesn't affect the number itself at all. It just tells me that I got to make that negative after my guess once I've taken the square root. Here's what it should look like on some of the homework problems today when you're approximating what the square roots should be. Last thing you'll do on some of the assignments, or last thing I want to go through to help you with some of the problems on the assignment, are some of these conditional statements or true-false statements like we've done in the past in this class. So just going through a couple examples here of what you might see. Sometimes they're in if-then form, where it says like if this, then this. These also work though too for true-false. Even if it doesn't have if then, it's kind of like the same type of deal where it says all square roots, like this first one says all square roots of perfect squares are rational numbers. You're trying to say, is that always true, or can you think of a time when that's false and you can give a counter example? So it says all square roots of perfect squares are rational numbers. Well, if we look at our list of perfect squares, just as a reminder we made earlier, okay, here are perfect squares. Numbers like 1, 4, 9, 16, 25, 36, 49, 64, all those types of numbers. Well, the definition of those is when I take a square root of it, I'm going to get a whole number. So in this case, well, are all whole numbers, because any square root that I take is going to be a whole number. Are all whole numbers rational numbers? Well, yes, they are. So this one I would say is true. That statement's true. That next one, all repeating decimals are irrational numbers. So again, you're saying, well, are all repeating decimals? They fit in the category of irrational numbers. If we remember from the chart we've made in the past here that I've had you write down, if I'm talking about repeating numbers, like here, 0.3, okay, 0.3 repeating, that's actually a rational number. So that tells me right away that there must be something going on with this one. So it's actually in the wrong category for what they're talking about. So all repeating decimals are irrational? No, that's false. Because actually all repeating decimals are rational numbers. You could show this by correcting that statement, or you can just give a counterexample also, as it says up here, give a counterexample if you know it's false. So I'm just going to choose that one, 0.3 repeating. That's a repeating decimal, but it's actually a rational number as we looked at it on our chart. And that last one, all real numbers are rational numbers. All real numbers are rational numbers. I'm going to refer back to our chart here again. This chart says here are all real numbers, okay? So it's saying that all real numbers must be rational, okay? Well, again, in this case, is this true or false? Well, I would say this must be false because, as you can see, there are also rational numbers. Real numbers are made up of these two categories, these two subsets. They're made up of rationals and irrationals. That makes up all the real numbers, actually. So I'd say no, that all real numbers are not necessarily rational. There are irrational numbers too. So as I go back to my problem here, I would say this one also is false. And then give a counter example. All real numbers are rational numbers. No, that's not true, because an irrational number is real, but it's not rational like it wants this statement to say. So I'd say that's false. Give it some kind of irrational number like pi. Pi is a real number. It's not rational. So they'll be dealing with a lot of problems like this today. Some true-false statements, and also some dealing with the perfect squares. Some dealing with the perfect squares and approximating square roots without a calculator, or at least trying it first without a calculator.